think.
I was going to ask, am I winning?
No, I think I'm winning.
Man.
I think we're around page probably about 280, 282, 280. Thank you, Summer. Okay. There, I know we were in the 270s yesterday. We're skipping to where it says using fundamental identities. So find that one. We did not finish the page, all the notes yesterday. We're not going to finish them. We're just going to keep moving.
283.
283, Mr. Rondo says. So because we really don't need some of this stuff to get us to where we're headed, which is calculus. That's our goal, is to get you what you need. Little preview of what you need for calculus. All right, I am recording. I'm going to go ahead and present my screen because I get to do the first 4 examples today.
Yay!
Yay! All right, we should be seeing my screen now, hopefully.
Yes.
All right, and I'm going to go here and flip this so you guys see the ceiling. Oh, I need to. All right, so essential question for the day, and we're gonna split this into 2 days. So we're gonna do half today and half on Tuesday. We won't have class on Friday, and Monday is actually Memorial Day, believe it or not. So we won't have class on Monday. So we're gonna do Tuesday, Wednesday, Thursday, and that'll be it. So our essential question is, how do you rewrite a trigonometric, I'm just going to abbreviate it as trig, expressions in order to simplify and evaluate trig functions and to verify trig identities. That's a long one today. And to verify, I'm not sure I'm spelling that right, verify trig identities. And I know I wimped out on spelling the word trig out. Sorry.
Mrs. Ballard, we are tied, just so you know.
Oh, we're tied. Oh, I better get one more. Has Brody shown up yet?
No, Ashley's not here either.
Oh, Ashley's not here either? Oh, all right. Okay. So I'm going to give you guys a couple seconds to, I have a thing in here that I'm missing on. All right, I'll go through it. I have stuff that's in the PowerPoint but isn't on my screen, so we'll just go through it again off the left side. Okay, so what I'm missing in here is if you flipped a few pages back in your notes, we have written down some of our identities, okay? I'm going to make a note of them in the left-hand column so that we've got them there again. Just to refresh our memories. We have what we call the reciprocal identities. No, I don't know if I'm spelling that right. We've got sine, which we know, and it's really sine. I really should be proper about this. Sine of x equals 1 over cosecant of x. So it's just they were reciprocals. So cosine of x equals 1 over secant of x. And tangent of x equals 1 over cotangent of x. And then I could go the other direction with them too. If I have cosecant, I know that that's 1 over sine x. If I have secant, I know that that is 1 over cosine x. And if I have cotangent, that's 1 over tangent of x. So that was one version of identities that we've had. We've also had what we call the quotient identities. And that is when we know that the tangent of x equals the sine of x over the cosine of x. And the cotangent of x has to be the reciprocal of that, is the cosine of x over the sine of x. We've got one more set that's going to be super handy today. These are going to be your friend and mine, the Pythagorean identities. And I believe we've gone over these before.
We have.
But, it doesn't hurt to do them again. So we've got sine squared x plus cosine squared x equals 1. And again, it's the Pythagorean theorem tells us something squared plus something squared equals something squared. And that's all this is sine squared, cosine squared equals 1 squared. We just don't put the squared on the 1. Then we also have a relationship between tangent and secant. So 1 plus tangent squared x equals secant squared x. And you're going to see this relationship between tangent and secant carry next year into calculus. It goes together really, really well. And then the other one is 1 plus cotangent squared x equals cosecant squared x. So if you want to write them down again to reference, we'll give you another couple seconds to do that. And then I'm going to go ahead and go into the 4 problems that we've got to do. All right. I did put my unit circle over there to the left. I don't know if I'm really going to need it. I kind of don't think I do, because I'm going to do this with a slightly different approach, but I put it there just in case. So first of all, what I like to do is I like to make my little notation of all students take calculus. I like to figure out what quadrant I am in so I know that my answers are coming out with the correct signs. Okay. So in these problems, they give us some information. They give us some trig, a value, and then they gave me a little bit of information about tangent. And I'm supposed to find all 6 trig functions, which I've already got secant for free. Yay. That means actually, before I even look at it, I know if I've got secant for free, I have its reciprocal cosine. So cosine of u just has to be the flip. So I've got 2 down, 4 to go. Okay. So if I think about where this is, so I make sure my signs are correct, I know that my secant is negative. And if I think about my secant, I know that that goes with the cosine stuff. So cosine has to be negative in quadrant 2 and quadrant 3. So I know I'm either in quadrant 2 or quadrant 3. I have to decide what's going on with tangent now. This tangent says it's greater than 0, which means it's positive. So when I only get to pick from quadrant 2 and quadrant 3, I know I have to have quadrant 3 answers because the tangent has to be positive. So what this means is that sine and cosecant should have negative answers. Cosine and secant, I'm sorry, that does not look good, have negative answers, and tangent and cotangent would have positive answers. So I'm going to keep that in mind as I'm doing my problems. And I already found my secant and my cosine, and they're both negative. So the next thing I'm going to do is I'm going to try to use some of my identities over here to create my other ratios. Okay, oh, sorry, hitting buttons. All right, so I'm going to choose to use this one right here because I know I've got cosine and I'm going to try to find sine next. So I'm going to use the fact that sine squared plus cosine squared equals 1. So I know I've got sine square x squared, and I'm going to write it like that, which is another valid way to write it. Plus, then for cosine, instead of writing cosine, I'm going to write this negative 2/3 squared equals 1. So I've got sine x squared equals, when I square the negative 2/3, I know that it is, plus sign. It is 4/9. And I know in my next step, I'm going to have to take that 4/9 and move it to the other side. So I am going to work smart and not hard and make that into a 9/9 instead, which is the same as 1. I'm now going to move this guy to the other side to solve for him. And notice the parentheses have to be there because it's the same as saying this. And this means the x is squared, not the trig function is squared. So be careful. That's the no-no. When I move this over, I get 5/9. And then I'm going to undo the square by taking the square root. And remember, it's a plus minus square root. We'll deal with the sign here in just a second. So we got sine x equals the square root of 5 over the square root of 9 is 3. Now, we said we had to be in quadrant 3, and we already know that our quadrant 3 answers have to be negative for sine, so I only want the minus version of this. Now, the bonus of having that is once I have that, I know that the reciprocal, I get the reciprocal for free. So the reciprocal is cosecant of x. It doesn't matter where my negative goes, it can stay up top. I'm going to flip the reciprocal, and then I'm going to rationalize it. So I know the cosecant is negative 3 square root of 5 over 5, because square root of 5 times square root of 5 is 5. All right, so now I have to figure out another relationship. I could go in, I've got secant, and I do have a relationship between tangent and secant, but I'm going to show another one just to do something different and see another way that this is put together. So I could use this one, okay? I'm going to choose to use this one because I know the sine and I know the cosine. So I'm going to use the quotient identity to find the tangent. So let's find a different color here. So I know that the tangent of u, I put an x in there somewhere, didn't I? I shouldn't have. It should have been u's. I apologize. You really shouldn't change
Wow,
it.
Mrs. Ballard, so embarrassing.
I know it is. All right, so I know I got to get the sine over the cosine. So the sine is this guy right here. So negative square root of 5 over 3. And the cosine is this one right here, negative 2 over 3. And the double negative we know is going to go positive. And then we saw this shortcut a couple of times now more recently that when we have those denominators the same, we could just cross them out. So my tangent is the square root of 5 over 2, which it came out positive, which is what we were expecting for quadrant 3 answers. And now I just get to simply flip that around, flip the reciprocal, and rationalize. And I've got the cotangent. So 2 square root of 5 over 5. All right, I'm going to pause for just a minute. Make sure if there's any questions, Ms. Rondo, let me know.
I actually have not a question, but when I do this problem, I do it completely differently. So I'm wondering if there's any benefit to showing the other way.
You use the triangles?
Yep.
We did it. You did it with triangles the other day.
Okay, fantastic.
So you guys can go back and do the triangles. The purpose of this section was to use the identities.
The identities, of course. Of course.
Yep. So we're showing how we use the identities today. All right.
One thing I do like about this that I would point out for our students is that sine squared, cosine squared that Mrs. Ballard pulled at the very beginning, the sine squared plus cosine squared equals 1, that is Pythagorean theorem. If you do the triangle version, you have to do Pythagorean theorem in it. So you're really actually doing the same math. This way is just the focus on trig. It's really interesting. I really enjoyed that because I'm a math nerd. Okay.
Yes. Aren't we all? We're doing math at 10 o'clock on Thursday. We're all math nerds.
That's right.
Okay. It's cool to be a math nerd. All right. Isn't it, Andy? Is it cool to be a math nerd, right?
Yeah.
Yeah. No paragraphs for us. Just math problems, right?
No.
Okay. So we're going to talk. This time we got slightly different information that we're starting with. Oh, well, we have secant, and they actually gave us tangent. So look at this, you guys. I'm not even going to look at my signs yet. I have secant and I have tangent. I get 2 of these guys for free because I get to flip the reciprocal on secant, which means that's cosine. There's a 1 in the bottom. So cosine of theta is 1/2.
Woohoo!
And then I also get to flip the reciprocal on tangent. I know there's a 1 in the bottom. So I get the cotangent of theta equals negative 1 over square root of 3. And I flip and I rationalize it. So negative square root of 3 over 3. So I just got 2 for the price of 1, kind of. Okay, twice. So I only have to find sine and cosecant, which means I really just need to find sine. We do want to check out what quadrant, though, just to make sure. So I'm going to do my little all students take calculus. I messed up. Students, I got to the T before I should have. Students take calculus.
Okay.
So I am looking at secant. Secant's positive. And positive secant happens where cosine is positive, and cosine's positive in quadrant 1 and quadrant 4. And then we're looking at tangent, and tangent was negative, and we know out of quadrant 1 and quadrant 4, tangent is negative in quadrant 4. So we need to have quadrant 4 answers for this. So, which we already do. We know we got our cotangent negative and our cosine is positive, which is what happens in quadrant 4. So I'm going to use since this is a 1/2, and I'd rather work with the 1/2 than the radicals, I'm going to use this identity again here, okay? So I'm going to use that sine of theta squared plus 1/2 squared for the cosine equals 1. So sine theta squared plus 1/4 equals 1. And it's, instead of 1, I'm going to work smart, not hard. I'm going to turn it into 4 over 4 because I got to move the 1/4 over. So sine theta squared equals 3/4. And then I'm going to undo these squares. So I'm going to take the square root of both sides. Remember, technically it's plus minus. And we have sine of theta equals, and then when I take these, when I reduce that square root, I get square root of 3 over 2. If I am in quadrant 4, I know that the sign in quadrant 4 is negative. So I know I'm only going to keep the negative sign. And we're almost there. We just got to flip the reciprocal for cosecant. So cosecant of theta equals negative 2 over square root of 3. I'm going to rationalize that. And I get negative 2 square root of 3 over 3. pause another minute here, a couple seconds to let you guys get through that part. Well, they keep getting easier instead, less work instead of more work on these.
Yeah, I feel like that first one was a beast, but these are
The
not
first
so bad.
one was a beast, but it showed a lot of different identities. So
that's probably why it was first.
Yes. Yes. And I didn't need my little unit circles to the side at all. Okay. 2 examples and you get to tell a joke, Andy, okay? All right, here we go. So let's look at example 3. Again, I always know that there is always a 1 in the denominator. Okay, sorry, my phone is not on silent. And I'm going to flip. As soon as I see reciprocal identities, I can flip. I'm flipping reciprocals. So then I get some points, right? If I'm taking a test in this, I get some points. So I'm going to flip this and I get -1 over square root of 2. And I'm going to rationalize that, which gets me negative square root of 2 over 2. Tangent, so reciprocal is cotangent, so I'm going to flip that. And the reciprocal of 1 is just 1. All right, now I need to figure out what on earth quadrant am I sitting in. So I've got all students take calculus. All right, so I know my cosecant is negative. Cosecant's negative where sine is negative, and sine is negative in quadrant 3 and quadrant 4. Then I know that the tangent is positive. So out of quadrant 3 and quadrant 4, quadrant 3 is the winner. So I need all quadrant 3 answers. So I'm going to check the answers I have. Sine is negative. I know sine. Only thing positive in quadrant 3 is tangent and cotangent. So that one works out. Cotangent is positive. I know cotangent and tangent are positive in quadrant 3. So that one works out. So I only need to get, it looks like cosine to get to secant. So what did I do on this one? I'm looking and seeing what I did. It looks like, okay, so I'm going to show a slightly different way. I could go back and I could use this identity again, but I'm going to use the quotient identity just to show you, okay, another strategy on this one. So I'm going to go back and use my tangent identity equals sine over cosine x. I'm going to write that one down. So tangent, I'm abbreviating, equals sine over cosine. So I know the tangent equals 1. I know that the sine equals this guy right here, negative square root of 2 over 2. And I need to find the cosine of theta. Okay. So I'm going to move this like it's a variable to the other side. So when I take this and I multiply it on both sides, I'll show that in a different color. Cosine of theta, cosine of theta. I get cosine of theta equals, these guys cross out, negative square root of 2 over 2. Which, yay, that was way even faster than all the other ones. So if I had done Pythagorean, it would have probably made more work. It doesn't matter though. You can use a variety of strategies and you're going to get to the same answer. That's one of the awesome thing about trig. There's a lot of different ways to put it together. Makes it fun. So I am in quadrant 3. I do have a negative, so that's good. And then I need to flip my reciprocal. And there's I'll show you, once I flip it and do the work, I'll show you what I would have probably thought about with this one. I'm going to flip it. I got 2 over square root of 2, and then I'm going to rationalize it. So negative 2 square root of 2 over 2, and these would cancel. It's just negative square root of 2. You're going to see the square root of 2 over 2 quite a bit, and you should understand that it is equivalent to 1 over square root of 2. And then you could have just flipped the reciprocal, or I could have come back up here where I had the sign and written it, that grabbed it from there, and that would have just made my arithmetic easier. It's not a big deal either way. You can use the you can go the long way and have to just rationalize. You're just looking for where you can make mistake or make less mistakes. All right, how are we doing, Miss Rondo? Anything in the chat?
Nope, we're doing good.
Okay, awesome.
I like it.
Okay. Oh, apparently some of my stuff is cut off here. All right. So
how will you ever figure it out?
I know, it's rough when it's a Pythagorean triple here. Okay. So that's what it should have said. Again, I have things. I could get things for free off of this, so I'm going to do that first because I like it when things are free. All right. The cosecant of theta, when I flip that reciprocal, we've got negative 13 over 12. And the reciprocal of cotangent would be the tangent of theta, which equals negative 12 over 5. All right, so I've got a whole bunch of stuff for free. I'm going to test out my all students take calculus and make sure I am in the correct quadrants, or I know which quadrant I'm working out of. So sine is negative. I know sine's negative in quadrant 3 and quadrant 4. And then I gotta go to something totally different. Tangent or cotangent is what was originally given. Either way works. Cotangent is also negative. So out of these two, cotangent negative would be quadrant. Those didn't turn out to be different colors. All right.
They're so sparkly and pretty, though.
They are sparkly and pretty. See, you gotta work in OneNote next year because you get sparkly, pretty pens.
I think so.
We got lots of choices. Look, there's all kinds. Oh, I can't use a red one though. That's no fun. Let's see. The red. That's too Hemet high. But look, there's a sparkly kind of greenish tealy one. Let's look and see what that one looks like. Well, there you go. We got some little bit more Talkwitz there. So
a little more.
Yeah, sparkly pens are some of my favorites. So all right. So we got to get. I digress. So we get back to, we've got to figure out, it looks like we're missing secants. So we've got to figure out how to relate secant to one of these. It doesn't, or cosine or secant. I'm going to go cosine. I know I'm going to go back to Pythagorean because I like Pythagorean identities. So I know that I've got sine squared plus cosine squared equals 1. And again, I'm abbreviating that and writing it down because that's how my brain processes that. I know I've got to fill in that formula. And then, so my sine is negative 12 over 13, and I've got to square that, plus the cosine of theta, and I'm going to put that on the outside of the parentheses, equals 1. I'm rounding out of my space here. Negative 12 over 13, when I square that, is 144 over 169, plus cosine theta squared. Ooh, I'm going to work smart and not hard. I'm going to turn that 1 into 169 over 169. Then I need to take this guy to the other side by subtracting. So I end up with the cosine of theta squared equals 25 over 169, some of our favorite square numbers there. I am taking the square root, plus and minus right now, because we don't know how it reduces yet, or which one it is yet. So cosine theta equals 5 over 13. I know I'm in quadrant 4, so my answer has to be positive. You don't have to write the little plus sign. I do that in my brain because it's like a check-off box. Oh, I checked the sign. And then, yay, we get this one. We get to flip the reciprocal for free. We get 13 over 5, and we are done. Is my class winning yet?
I didn't check. Okay. I ignored it. We tried. That was good enough for me.
We're tied. We're good enough. All right. Do we have any questions, comments, concerns? I know that it's tedious work. It's not hard, you guys. It's just tedious. It's kind of a pain, but it's fun. All right, I'm going to have Andy come on here because he's waiting. He's sitting here eating his goldfish, and he's going to tell us a joke. All right, can you swallow your goldfish? I think I stopped sharing. Yes. Okay, so tell it. You have 2 jokes today, right? Because we're making up because we missed a few days. All right. All right. So what's joke number 1?
So, why are obtuse angles always depressed?
I don't know. Why are obtuse angles always so depressed?
Because they're never right.
Oh, kind of like husbands. All right. So husbands are right sometimes. Okay. What's our second joke?
What do you get when you cross an algebra class with prom?
What do you get when you cross an algebra class with prom? I don't know what. Gotta go look it up. Okay, tell us that. Do it again.
What do you get when you cross an algebra class with prom?
I don't know. What do you get when you cross an algebra class with prom?
A quadratic formal.
A quadratic formal. That's a good one.
Yeah, very nice.
All right. Okay, Miss Mondo, take it away.
All right, so let me flip my screen around here. Okay, hopefully you guys are seeing all the good stuff. Okay, so this in your notebook should be on page 284. We're looking at cofunction identities. We did these before a while ago, but we're going to come back and look at them here, specifically looking at them in radians. So this is with pi over 2. That would be equivalent to 90 degrees. But notice all these, we are using radians to write our identities. So I want to remind you, cofunction That is a hint that we're going to be looking at complementary. Then here we go with the spelling, complementary. Wow, that is like horrible.
That's
Apparently
okay. It's better than mine. So I wouldn't even spelled out the word.
Complementary, that's a little bit better. Angles. Okay, so cofunctions have a relationship when you talk about complementary angles. And a way that you can remember cofunctions is these are the same name. So we're talking about sine with cosine, tangent and cotangent, and then secant and cosecant. They have a relationship. So same name. They are cofunctions. That co is important. Okay, so complementary angles. If we work in degrees for just a minute, just to remind you about how this works. If I say that x is 50 degrees, and then I say, okay, what's the complementary angle for that? I would ask you in the chat, but we're not going to waste, it's not wasting time, but we're not going to worry about it. I'm pretty sure we know that we go, oh, I take 90 and subtract the 50 degrees. I know that gives me the complementary angle of 40 degrees. So we see that relationship where I take the 90 degrees and I subtract the x, or the 50 degrees in this case, to get the other angle. So if you look over at, let's look at the first one, sine of pi over 2 minus u. This is basically the same as saying 90 minus x, and this is cosine x. So the two angles in our problem are complementary. They're complementary, and so the functions themselves have equal values. So we talk about this in geometry. We've talked about it this year already. So complementary angles, the functions are equal, or equal functions, cofunctions, means the angles are complementary. All right, so then if we jump down, so that works for all of them. And then if we jump down to the even odd identities, I believe this section Mrs. Ballard went over with you guys. So basically everything except for cosine and secant, these are a little different. These are your even functions. The other two are odds, but the other four are odd functions. Essentially, when I do looking at cosine and secant, because they're a little different, when I plug in a negative angle value, I get the same thing as if I plugged in a positive angle value. So they're equal. Whether I use a positive or a negative, the end result is the same. It's kind of like saying, if I have y equals x squared, if I plug in a negative or a positive for x, if I plug in 2, or if I plug in -2, my answer for both of these is going to be the same. So that's the even function world. So cosine and secant are even functions. The others are odd. When we plug in a negative angle, like for sine, we end up with the answer being affected, being a negative value for the answer, so negative sign. So they work a little bit differently, but that's just a quick refresh. All right, so we're going to look at example 5, use the given values to evaluate, if possible, all 6 trig functions. So we're going to start, I'm going to start with this first one, sine, and then I see pi over 2 minus x. Remember, that's a lot like saying 90 minus x. And you guys have it right there as a reference. I forgot you guys had to write it down. Oh my goodness. I apologize. Going back to this one, that you guys need to fill in all these answers. Whoops, sorry, got ahead of myself. I'm going to pause then and give you another couple seconds to write all these things down that I'm circling. I am so sorry, I forgot why I do that. Hi, Mrs. Ballard. Any questions in the chat?
I do not see any questions in the chat.
Good, then I'm going to take a drink of coffee. That's important.
Awesome. Did you finish laying the bricks in your backyard?
It's in the front yard, and no, we're almost done. We ran into a slight issue with our watering system that Jeffrey has fixed and refixed, and we keep having a problem with it. So we'll see. Okay, so hopefully that gave you a couple more seconds, guys, to catch up with me. If not, it will be, of course, Mrs. Ballard and I will both post this, so you'll have access to that. So you can get those values later, but I just want to make sure we have that reference. Okay, so going back to example 5, I have sine of 90 minus x. So when I see that pi over 2 or 90, that's reminding me this is a complementary angle situation. So if I'm going to look at the complementary angle, would just be the x. This is 90 minus x. And then the cofunction that goes with it is cosine. And that's going to have the same value. Sorry. Okay, that's going to have the same value as sine. That's the cofunction identity, is the complementary angles. You have the same value for your functions. All right, so then if I look at that, now my angles are both in terms of just x. I'm going to go back to, you guys have practiced this a couple times already today. All students take calculus. And I want to make sure that I'm in the proper quadrant. So you guys can still see me, okay. All right, so I'm going to make sure I'm in the proper quadrant. Cosine is positive, sine is positive. Cosine is positive in quadrants 1, and that A looks horrible. Okay, 1 and 4. And then I need sine to be positive. That's going to be quadrant 1. So I'm in quadrant 1. All my answers are positive. That makes it nice and easy. All right, so I want all 6 trig functions. Since I already have sine and cosine, I'm going to steal, just like Mrs. Ballard did. It's much easier to work for free. If I have cosine, that's this also giving me secant. So secant would be the reciprocal, 17 over 8. And then over here for sine, the reciprocal would be cosecant of x. And then I'm not saying that very well. I'm so sorry. Sine and cosecant go together. The answer for cosecant would be the reciprocal of sine. There we go. A little bit better. All right. So I have 4 out of the 6. The only ones I'm missing are tangent and cotangent. So I'm going to also use some of those fabulous identities. This one cannot be overstated how valuable. Tangent of x is equivalent to sine over cosine. And so I'm going to steal my sine over cosine. And so my sine was 15 over 17, and my cosine was 8 over 17. There's that little handy rule. If we're dividing, if our denominators are the same, we can cancel those out. So I get tangent is 15 over 8. And then for cotangent, all I have to do is the reciprocal, 8 over 15. Any questions or concerns?
I do not see any in the chat. They're quiet today. We haven't asked very much of them, though.
We have not. Just plowing through. All right. This one will be a little bit, I am going to ask a question on this one. Okay, so looking at the problem on this one, the first thing I have is cosine, and it says negative x. If you go back to those identities, this cosine is an even function, which means cosine of negative x will equal 2 over 5, and cosine of x will equal 2 over 5. That's that even function rule. Cosine of negative x is the same as cosine of x. They have the same answers. All right, so that gives me cosine of x. So once again, I'm back to having matching angles. Dealing with the same angle is important. So we have cosine of x and cotangent. And then also I want to right away get my trig functions for free. So secant would be the reciprocal, 5 over 2. Cotangent, I would do tangent. This one's going to be just lovely. Tangent of x would be 21 over 2, 21, or 2 times the square root of 21, which is a mess. If you are good at, I shouldn't say good. If you have practiced this a lot and you can see it, without me rationalizing, here we go for that question in the chat, without doing the full rationalization, looking at cotangents, going back to the original cotangent, what was cotangent before we rationalized it? So this is the rationalized answer. Is anyone brave enough to tell me what cotangent would have been before it was rationalized?
Interesting.
And that's a thinker. It's going to take a couple seconds on that one.
Yes, it will. Nothing yet.
We'll give it a couple more seconds because that's a tough question.
Still nothing.
All right, last call.
Oh. Square root of 21 halves. Negative 2 square root of 21 over square root of 21.
Negative 2 over square root 21.
I also had square root of 21 over 2.
square root 21 over 2. Okay, so I love both of these answers, honestly. The second one, I think we just forgot about the negative, which I'm not worried about for this particular question. I love that we see that those two answers show that we know there's a 2 in the fraction and we know there's a square root 21. So that honestly would be what I'm looking for. Do we see that because there is a square root 21 here, that meant there should have been a square root 21 in the original problem? Specifically, if we rationalized it, that square root 21 would have been in the denominator. So that tells me this one is probably the correct answer there. But I love that we see that square root 21 pop up. That was excellent. Thank you guys for being brave and sharing. I'm going to get rid of those so we don't get confused on the screen what's going on. So definitely, if you are able to see what it came from, then that can be helpful, so you can just flip what it was originally. But if not, this will work. We can deal with rationalizing. It's not a big deal. It is a handy skill on ones that are a little more common, like our unit circle ones, like square root of 3 and square root of 2. Those you'll get much more comfortable with. This one was a little tougher because it says 21. But good job. Okay, so when I do this, I get 21 over square root 20, times square root 21 over 2, and then my square root 21s, remember, if they match, the number it's just the number that was inside. So square root 21 times square root 21 is just 21. Then I could multiply that together, 2 times 21, but I'm going to end up canceling because 21 and 21 are going to cancel out. So I have 21 over 2. And I did the thing that I said, that I actually commented on. Don't worry about the negative. We absolutely need to worry about the negative. I apologize that I left it out. That should have been included the entire time. Okay, so I have cosine, I have secant, I have cotangent, and I have tangent. I need to make sure that these answers, I did not double check. I want to make sure that all my answers are done correctly. All students take calculus. I have cosine of x is positive. Notice I went to the x version. This one is positive, so I'm in quadrant 1 or quadrant 4. My cotangent or my tangent, both of them are negative, so that means I must be in quadrant 4 because this one they would be positive. So I'm in quadrant 4. When I go to do, I'm looking for sine and sine and cosecant, I'm going to be in quadrant 4. So I should have negative answers for the last one. All right, for this one, I don't remember what I did before. Let's see, we need to get sine. I could do a tangent doohickey. I could do a
You guys,
cosecant.
you're missing sine still. So you either could do a reciprocal identity or a Pythagorean identity.
Yeah, I have some options. I kind of want to do a Pythagorean one. We did a reciprocal one on the last one.
Awesome.
And I actually want to do the cosecant one. Mrs. Bauer, can you hook me up? I don't know it by heart at this point, and my brain's not going to help me out.
The cosecant of, the Pythagorean one?
Yeah.
Cosecant, I'm losing it too. I'm gonna look it up. I'm gonna make sure we've got it. Right, okay. 1 plus cotangent squared equals cosecant squared.
Okay, thank you.
Sadly, we can let this little group in on something that you hardly ever use cotangent and cosecant in calculus.
Okay, I want to use it here anyways.
Yes, use it there, please.
Okay, 1 plus cotangent squared equals, it should be cosecant squared.
Cosecant squared, yes.
Yeah, I just forget which one is on which side.
Yes.
without doing the math. Okay, so I'm going to fill in. I have 1, that's easy. Plus my cotangent, I'm going to fill in. Remember, as Mrs. Ballard showed, this cotangent squared is like saying cotangent x squared. So I'm taking the cotangent and I'm going to square the value. So my cotangent was -2 square root 21 over 21. Lovely. And then I'm making a big mess of this one. All right, cosecant squared is the one that I want to know. I'm going to leave that. That's what I want to know. All right, so then I have 1. I'm going to leave the 1 for a minute. Plus, when I square this, it's going to be a lovely mess. I take the -2 in front and square it. I get 4. I take 21, square root of 21 and square it, I'm going to get 21. And then on the bottom, I'm actually going to do something a little bit funny here because I don't have a calculator and I don't want to really calculate it out. I'm going to say it's 21 squared.
Ooh, I like it.
Yeah. All right. So then part of my thinking is I see there's a 21 in the numerator. So when I go here, this is 21 to the first power and 21 to the second power. I can use some exponent properties. Who would have known? And I can simplify that and say, hey, this is really 4 over 21. That is 121 cancels in the top, and I cancel out 1 in the bottom. There's 1 left over. If you're not sure what I did, I'm going to write it out to the side. I had 21 in the top and 21 squared in the bottom. That means there were 2 of them. I canceled 1 out. Hopefully that clarifies. All right, then I still have my 1, which I'm going to immediately turn it into, I can make it any denominator I want by making the top and bottom match like Mrs. Ballard showed, 21 over 21. I get cosecant squared x. And if I add those together, I'm going to erase this actually, sorry. All right, and I'm going to move this over. So I have 25 over 21 equals cosecant squared, and then square root both sides, and I get the plus or minus 5. I can't do 21, doesn't come out nicely. So I have cosecant x is plus or minus 5 over root 21. We got to fix that, but I want to double check. Ooh, question for the chat. Is cosecant supposed to be positive or negative? What did we say?
So is cosecant supposed to be positive or negative this time?
I'm drinking more coffee to help my brain. It's a little slow today.
How many lines do I need?
I don't know. Give me like 4. Okay. They need coffee too, apparently, Miss.
I need to share my coffee. It's like share the candy, share the coffee.
Pass the candy, yes. Pass the coffee.
We don't know
today. They aren't saying anything. They're quiet.
Positive or negative.
Oh, I got a positive.
Okay. Positive? Are we sure?
I got a positive with a question mark.
Okay, not sure. All right, so if you're not sure, go back to the All Students Take Calculus. We circled quadrant 4. That C in quadrant 4, be careful, means cosine, not cosecant. It means cosine. So in quadrant 4, cosecant would be negative. The only ones that are positive in quadrant 4 are cosine and secant. So we want the negative version. We're also going to sneak in a quick rationalization here. So I would have negative 5 root 21 over 21. There is my cosecant x. Fantastic. It was very messy with that one, but very fun. Because I'm crazy. I like to do things a little crazy, I guess. All right, let's go on to the next section, which these are actually so much fun. We get to use all those identities all together in one shot. So at the top, our directions match the trig expression with one of the following. So this represents all the possible answers we're going to get for this section, 7 through, I think it's 11. All right, so I have cosecant and sine. I surely hope when you see cosecant and sine, you know that they have a relationship. They are reciprocals of each other. So I'm going to use a reciprocal identity, and you can do it with cosecant or with sine. I typically like to revert back to sine. It is my favorite. So I'm going to turn cosecant x into 1 over sine x. And then I still have times the sine x that I had in my original problem. If I put a 1 under that and multiply across, I get sine x over sine x. And that will equal 1. So this one, the answer is 1. Awesome. Questions? See any in the chat, Mrs. Ballard? We're good. You might have lost Mrs. Ballard.
No, I'm here. Oh. I had the microphone off because Ellie was in here working on her math. Because she's doing a math test today.
Ah, fun. Okay.
She didn't know what factoring was. No questions in the chat, though.
Okay, great. All right. So then this one, cotangent and secant. So Again, lots of options on how you could deal with this. I'm going to probably stick with my reciprocal identities a little bit here and my quotient identity. Cotangents, I could rewrite, and this is all about just picking something you can rewrite it as. Typically, one of the strategies, if we went further into trig stuff, which we won't so much this year, but one strategy that we talk about is a lot of times if you don't know what else to do, one thing you can do is turn everything into sine and cosine. Try that. Sometimes that will help you find your path. But so I'm kind of using that in the back of my mind. You guys haven't really been instructed with that a ton, but that's kind of where I'm going here. Cotangent, I can call cosine over sine. And then secant, I know I can turn that one into 1 over cosine. And then when I see that, I go, oh yeah, the cosines cancel out. I have 1 over sine, but I don't see 1 over sine in my answer choices. Any ideas as to what the answer might be? Let's get you guys in the chat again. What should the answer be? Did I do it wrong?
Yeah, that's tough. It's not one of our choices.
Oh, Miss Rondeau doesn't know how to do math, so I must have done it wrong.
Anybody got any ideas on instead of 1 over sine, which one of it should be? It's a -1 sine cosecant, cosecant squared. We've only got 5 choices to guess from.
Right? Actually 4, because we already used up 1.
True, though it could repeat. I don't know if it does.
It could. I don't remember if they do or not. That's true.
I don't think they do. But, oh, I got a cosecant x from Cynthia.
Cosecant x. Sine and cosecant are related. They are reciprocals. So 1 over sine x actually does equal cosecant x. Nice job, Cynthia.
Awesome.
Very good. So now that would be our answer here. On to the next one. This one, anytime you see trig functions squared, you should probably go check out your Pythagorean identities because chances are it's one of those. That's often how that works. So on this one, I see tangent squared and secant squared, and those two are the ones that go together. That's important to know that tangent and secant go together. And so this one, you have some choices, but from your identities, literally the identity that I'm going to pull from, I'm going to jot it down for you, is 1 plus tangent squared equals secant squared. So I'm going to take, and I see, hey, I have secant squared right here, and I'm going to replace it with 1 plus tangent x. I'm sorry, tangent squared. All right, so I have tangent squared x minus, and I'm replacing that secant with 1 plus tangent squared x. Then, because I'm subtracting the whole thing, this would be distributing that negative. I get -1 minus tangent squared x. Tangent squared x minus tangent squared x. Those cancel out to 0, and I have -1. That's my answer. Awesome. Let's go through. We're almost to the end here. This one, again, when you see that squared value for trig functions, it's not a bad idea to check those Pythagorean identities. I see cosecant squared. So I'm going to go look at my Pythagorean identities, and I see that kind of looks like this one. Cotangent squared x equals cosecant squared x. So it kind of looks like that one, but not quite. This one I see I have cosecant squared x minus 1. We didn't talk about this a ton, but these Pythagorean identities, you can kind of move them around a little bit. If I subtract 1 from both sides of this Pythagorean identity, I have cotangent squared x equals cosecant squared x minus 1, and that matches perfectly what I have in my problem. So I'm going to steal this as a replacement for cosecant squared x minus 1. So I'm going to say cotangent squared x over cosine squared x. So now I still have squares. I could still look at my Pythagorean identities, but with a fraction here, and I'm going to kind of look at maybe that sine cosine skill I kind of talked about. So cotangent x is the same as cosine over sine. That would be one of our identities. It's our quotient identity.
But Ms.
So I'm
Rundell,
gonna,
that says cotangent squared, not cotangent.
oh no, well, there's this fabulous thing when we're solving equations that you can actually do operations as long as you do it to both sides. And that would in fact give me cotangent squared cosine squared over sine squared. Fantastic.
Oh.
That was a nice save, Mrs. Ballard. I like it. Yeah, so you can actually use that quotient identity on any exponent, with any exponent you want. I could have just as easily made, instead of a 2, I could have made it a 10 or 1,000 or 3,100 or whatever, and it would make all the resulting parts that same exponent. So, but that's kind of the why. What I just showed is how we get that. All right, so with that, this is literally going to be what I replace cotangent squared with. So in my fraction, my next step would be cosine squared x over sine squared x. And then the big overall fraction that we're working with, that was my original fraction bar right there, is cosine squared x. So here is where one of the skills we saw before is really important. I have this fraction divided by a number. This fraction bar, the big overall one, means divide. When we deal with fractions, the way that we show that mathematically is typically to multiply by the reciprocal. So I'm going to rewrite this as cosine squared x over sine squared x. That was my numerator. But instead of doing division, I'm going to multiply by the reciprocal. So the reciprocal of cosine squared x is 1 over cosine squared x. So multiply by the reciprocal. Excuse me, when I do that, cancel, cancel, I get 1 over sine squared x, and we have the same problem again. My answer choices do not say 1 over sine squared x. Using the same strategy from Cynthia, this is a reciprocal for cosecant, and so I can say that is cosecant squared x. All right, our lasty one. Let me circle that. There you go. Makes me feel better. Okay, last one. We have tangent x and cosine x. This one, I'm going to revert back to a lot of times when I see tangent. I love that tangent quotient identity, that tangent is the same as sine over cosine. So I'm going to say tangent is sine over cosine. And then I still have times cosine. And if I put a 1 under that to make it a fraction, the cosines cancel, and I get sine x. Final answer.
That was a quick one.
Yeah, that at the end, after the other ones, which were way more challenging than it was.
I
just
know.
like, oh,
It's always
was
nice
easy.
to have a quick one at the end.
Yes.
All right. So we will not see you guys again until Tuesday. But to give you something a little extra to do, because we know we can still earn some points, and I know not everyone's doing the assignments, but they're out there for you as a resource to get you kind of moving through this. It'll help you for next year. We are going to put out there, I know it's out there on mine, Ms. Rundell's probably going to put it up. We put out an activity, a Desmos activity, to teach you the graphing part of trig. Okay, so make sure you know the, or you know, it's out there. It'll be a Desmos thing. And again, everything you got to get done by the 29th of the month, which is next Friday. So my deadline's 5 o'clock. I don't know about Ms. Rundell's, but mine's 5 o'clock. So
mine will probably be 3, but I don't know. Well, maybe I'll match, because then I'll be nice.
You'll be nice. I just bought you guys 2 hours. Remember that next year.
That's right. Okay, so
we will see you guys next Tuesday. Okay.
Tuesday.
So have a good long weekend, guys.
Have a great weekend. Bye, everyone.
There's always one.
Yasmin.
Yeah.
You're still recording too, Mrs. Ballard.
Oh, am I? Okay, I'll stop that too. It will stop automatically, but I usually try to stop it so we get the recording.